E-Media Press and the Energy Science and Technology Conference. Today is February 10th, 2019, and it's 1 o'clock Pacific time. And we have Eric Dollard on the phone, so we'll just cover a couple announcements, and then Eric can kind of give an overview of what to expect at the upcoming conference. And then we'll go ahead and open up for questions. Let's see. Hi, Gene. I just saw you joined us. I'll go ahead and leave you unmuted in case you want to jump in at any time with any questions.
Okay.
Eric's website is ericpdollard.com. That's P for Paul, his middle name, so ericpdollard.com. And Eric is with the EPD Laboratories, Inc., which is a 501c3 nonprofit corporation. And the organization survives on donations, and so it is tax deductible. If anybody would like to help out with donations by either PayPal or check or money order, there's instructions and a PayPal button in the right column of ericpdollard.com. If you just scroll down, you can see that. Recently, he's been doing a lot of writing, and he's sending me up some notes that will be scanned and put into like Energetic Forum and on his website. And he recently sent me some updates on his versor algebra ebook, which has been available for the last several years on versor through versoralgebra.com. And as soon as these updates are edited into the ebook, it's going to be reformatted into a 6x9 paperback, which will be on Amazon, and can kind of be pretty time intensive depending on the formatting to get these on Amazon, but the goal is to basically get everything on there available as paperbacks in addition to ebooks. Our upcoming conference is the Energy Science and Technology Conference, and for 2019 it'll be the 8th annual one that I've helped put together. It started with John Bedini and Peter Lindemann, and after a couple of years we called it the Energy Science and Technology Conference to be a little bit more encompassing and kind of generic. And this conference is going to be July 11 to the 14th, which is a Thursday through a Sunday. And originally we were going to have an extra Monday for business-related presentations about legal issues, contract manufacturing, and different topics so that people can learn how to take their products to market, create the prototypes, get quotes, and then market them. And so instead of having an extra Monday, what we're going to do is have the business presentations in the evening after dinners on Thursday, Friday, Saturday, and Sunday, so that anybody who is interested in those presentations, that they don't have to stay for an extra day. The information for the conference is all on EnergyScienceConference.com, and it's limited to 150 seats. Every year it sells out a couple months ahead of the conference, and I just started to accept payments on February 5th, and already about 20% of the seats are already taken. So if you want to come to that, Eric Dollard will be there giving 2 presentations. Normally he gives a 1 hour one presentation, which is usually about 4 hours. Last year he gave a presentation called the History, Theory, and Practice of the Electrical Utility System, which goes into how the kind of the punchline on the presentation is how the grid has been kind of systematically degraded so that it actually becomes an antenna for EMPs, which would enable an EMP to actually cause more damage. And at the upcoming conference this year, he's giving 2 presentations. One is going to be on Tesla's Colorado Spring transformer, and another one is going to be on the seismic project. Eric, do you want to kind of give a basic overview of what both presentations are going to be about and what people can expect to learn from that?
So I forgot the title of the Colorado one. Do you have that handy?
Yeah.
What did I title it as? Because this is still in the formative stage. What was the
title? It's called the Theory, Calculation, and Operation of the Colorado Springs Tesla Transformer, and there will also be a demonstration.
Yeah, so this started off with an idea to build a scale model of the Colorado Springs unit that actually operates. That turned out to be a lot more difficult than was thought at first, because these things don't scale. In fact, many things don't. They'll work within an octave, but once you get beyond that, then all of a sudden things get out of proportion. And that's the reason why there's equal temperament in the musical scale, because you can't keep scaling without things starting to drift apart. So that's been quite a struggle. And then the Tesla Colorado Springs notebook, it appears that in that notebook he didn't really complete, as far as the notebook goes, he didn't really complete what he intended to do. So things were kind of left half done and what have you, so that had to be taken into account. So it's actually was quite difficult to come up with the 20-to-1 scale model to operate on 850 kilocycles a second as an AM broadcast band signal. But it was successful. It took about 100 pages of arithmetic experimentation to get this thing settled upon, and it is settled upon, and it's almost complete. So there'll be two of them that transmit back and forth to each other. As far as getting these things lit up and what have you, I don't know if that will be possible, because I'd have to spend a considerable amount of time in an alien environment working on this, which is difficult for me, but we'll see what happens. But at any rate, that will be the beginning of the presentation, and then I'll get into kind of the construction and the materials involved, and then I'll get into the basic principles of how this differs from a regular transformer, and what a transformer does to begin with, and then I'll get into a mathematical analysis with engineering solutions to the problem, which to date nobody has ever accomplished. So this will kind of be an adventure for me, but I have a lot of experience of this in the past. There's two very detailed papers on this subject, which are free on the internet. One is called The Condensed Intro to the Tesla Transformer. That was a writing on my efforts in my laboratory in the Marconi Powerhouse in Bolinas, California. And then later I wrote The Theory of Wireless Power. That's when I was constructing the Integratron, and the two of those are pretty thorough as far as laying out the principles of Tesla's telluric transmission system. Now, of course, there's a lot of people that claim that they've got it all figured out and what have you, and they're going to build this or whatever, and they sell their little Edmund Scientific toys, but none of those things, scalar waves and zeonic waves and all these things, Maxwell's equations, have absolutely nothing to do with Tesla whatsoever. So these people basically are just leading you around by a ring in your nose and not getting you anywhere, so I'm going to attempt to set this straight once and for all. Also, there's going to be another presentation on the now failed advanced seismic warning concept. There's absolutely no interest in that. The scientists and other people involved don't want to talk about it anymore. There's no money for it. But I will, as a finality or closing, point out the different aspects, the Alexanderson method, the magnetometer method, in other forms, if I can get the chief scientist of this project to cooperate with me and give me his views on the semiconductor properties of geology before the seismic event and the electrical and mechanical forces involved. I discussed this at length with him several years ago, but it's a very, very complex portrayal of the forces involved. The scientist's name is Dr. Friedemann Freude. He's written a number of papers on the subject. I don't know why this guy isn't a feature article in Scientific American, but then I do know why. It's absolutely the most brilliant expose of semiconductor and related activities in seismic situations that anybody's ever produced, and it's thoroughly ignored, and he receives no more funding for that research. So basically the project's a dead horse, so it will just be presented as a historical artifact, but nothing will come out of it. And the U.S. Geological Survey is also viciously opposed to any of these type of activities, just like the Institute of Electrical and Electronic Engineers is viciously opposed to anything that is the reality of Colorado Springs or Wardenclyffe. So this is the world we live in, and there's no getting around it. So presently, before I got on the phone, I am writing up elements of the last presentation. Usually I write a book on each presentation I give in the following year. And this relates to a number of equations and diagrams that I recently put on the website, which is kind of a new approach to Maxwell's equations and their extension for electromagnetic transmission based on the Heaviside concept. And so that will basically in 20 or 30 page blocks, that material is going out. A lot of it involves the rather sordid history of electrical science, and the bulk of it is actual quotes from the people involved, and some of these quotes are rather startling in view of the way people look at things today, and that these famous individuals in the 19th century were so opposed to a lot of the way things are looked at today with relativity and all that, and were very strictly adherent to the concept of the ether, which in view of Faraday's work is undeniable. And so I'm trying to bring all that back to life. It consisted of roughly 2,500 pages of reading over the past 4 months and several hundred pages of notes, so now it's getting finalized. So even though I don't have any laboratory situation or anything like that or anybody to help me with equipment, I do have adequate facilities and references to do a considerable amount of writing. The only complication is there's no longer enough donations coming in to buy the necessary books and references. They barely keep the lights on in the building anymore, so this operation is gradually going, as they say in mathematics, 1 over E, and I would estimate within a year I will have to fund this whole thing out of my pension, which will be very difficult. So that's basically the gist of what's going on now, and then I guess I'll turn it back over to Aaron.
So I did receive a list from Robert on 3 or 4 books that you need. I think there might have been J.J. Thompson's. I can't recall. I have the email. But anyway, we do have the funds to buy those books and have them sent down to you. And also, now for this Colorado Springs experiment, I still haven't received the final quote for all the pieces and parts and some of the labor and everything to help put this together. Originally, I had emailed out that we're looking at about $2,500, may do it. And there's been about, maybe about $1,200 in donations. And just for privacy, I won't say their names, but I do want to recognize those out there. A $900 donation came from a kind of a, not really sure what kind of organization. It seems like a financial organization that helps to support these type of projects, and they donated $900, and so that was obviously very welcome and very helpful. Now, when you say on the Colorado Springs with the transmitter and the receiver, and you say light it up, what do you mean exactly by that?
Basically, hopefully, the MWO pulse modulator will work directly into this unit because they both operate on the same frequency. So it'll bring it to a state of operation, scaled down, of course, similar to what Tesla actually had going in Colorado. Now, if that's not feasible because of time and complications, I'm hoping to get together a continuous wave oscillator, so at least all of the various fluxes and forces and voltages and currents and what have you demonstrated, so that way then the basic dynamics of the thing can be shown. It'll light up a fluorescent lamp and and move the pointer on an RF amp meter, but there won't be any, big sparks jumping everywhere. There'll be no sparks at all. In fact, in actuality, when these things are operating as telluric transmitters, they're not supposed to make any sparks. So this whole idea that Tesla coils are just something to make big sparks is actually the exact opposite of Tesla's intent. Something I have going in parallel with this, which is kind of a restricted project, but it's the working on the Tesla beam tube in parallel with the Rife beam tube that was actually used by Rife and has been his detractors or followers or whatever you want to call them very carefully erase these things and put their own ideas in. But it was in Rife Laboratory and held the tube, and I'm studying that quite intensely now, and to come up with a particular type of beam tube that might not exactly be what Rife had, but it will be very similar and perform similar functions, and it will be more in the terms of the Tesla one-terminal beam tube. So that is also a intensive study that I'm engaged in right now, mostly for theoretical purposes. But the tube has been identified and given a code number, and its size is determined and all that. So a model may get built at some point, but I do not really have the means to do those kind of experiments. But that's cooking along with the Colorado thing. So as most people know, Tesla not only was interested in these various forms of transmission in the Earth, but he also had a particular beam idea to convey electricity from point to point. And basically, Tesla was a co-discoverer with Röntgen on the X-ray and did extensive work on these discharge tubes and Crookes work and what have you. And a lot of what was discovered in there is applicable to the Colorado Springs because they operate on the non-Maxwellian idea of unclosed currents, and you have to go to Hermann von Helmholtz as an alternative to gain any insight into these unclosed currents. But his work, for the most part, has never been translated or worked. Heaviside worked on it a little bit, but not enough to carry it beyond Maxwell. But I am attempting that myself with the equations that I've developed in the past from Steinmetz and other people. And the beam tube as well as the telluric transmitter both exhibit these unclosed currents. In the case of the beam tube, they're called cathode rays, and cathode rays are not electrons, nor are beta rays. They are not electrons, and this whole idea of an electron really has screwed everything up. In fact, to quote J.J. Thomson, in his social gatherings in later years, he would give a toast, "Here's to the electron, may it be of no use to anybody." A rather startling statement to come from such a brilliant physicist who was given credit for discovering the electron, but maybe we need to take his advice. So at any rate, that kind of wraps up what's going on, so I can answer questions or whatever from this point on.
Okay. Now, with your Colorado Springs talk, obviously there'll be a disclosure on everything on how to replicate this. What kind of experience would you say somebody has to have in order to replicate the model you're going to show, or a variation of it?
Well, basically, it's just following the blueprints. The complication is this one does operate in the AM broadcast band, which was not particularly desirable because, there's other bands available for this kind of stuff. There's some experimental frequencies that have opened up in the old maritime band around 450 kilocycles, but that would have resulted in a unit too big. And then there's the 1.8 megacycle to 2 megacycle amateur radio band, but it would not scale that far without having absurd dimensions. So now the thing is as I think everybody's starting to get the idea, the Internet and digital is a totalitarian movement, and every effort is being made to take away all radio or alternative forms of communications or broadcast. and being that Europe is a leader in this movement, Europe presently has no more AM broadcast stations whatsoever. And so this actually might turn out to be, could be a rather major experimental movement in Europe to set up a telluric longitudinal broadcasting system in these abandoned frequencies, providing the government doesn't immediately shut it down or it gets destroyed by a terrorist attack. Here in the United States, some stations are difficult to get, particularly in remote areas like here in central Nevada. What the Tesla transformer will do is make these distant AM radio stations that are normally not receivable, make them come in loud and clear, not only to one immediate receiver, but can also make an entire town by connecting it to the this multiple grounded Y neutral. Could be used as a carrier medium and convey it throughout an entire town, or even just connecting it to a decent ground electrode without connecting to any wiring would facilitate that, and it would not be a broadcast in the normal sense because it's non-electromagnetic, and if it's confined to a specific municipality, it's not really that incredibly in FCC violations if the power is low enough. So there's some interesting experiments that can be done with this. Otherwise, it would have to be scaled into an experimental band.
Okay. Should we go ahead and open up for questions?
Yeah.
Okay. So if anybody has a question, go ahead and hit 5*, and that'll put a symbol next to your number, and I can go ahead and unmute you. Okay. Let's see. I'm unmuting somebody right now. Hey, Gene. Let's see. I'm going to lower that hand there. Go ahead, Gene.
Okay, Eric. I wonder if you could explain for kind of layperson where the Coram brothers have missed the boat, because I remember way back in the Tesla conferences of the 1980s, they were talking about resonating the Schumann cavity, and they were the big deal about Tesla's wireless work, according to conferences and books that were written in the meantime. And so a big deal has been made of their long time research. So where have they gone wrong? What have they missed?
Okay, it's kind of weak. Can you kind of give me a synopsis, Aaron, of what he asked?
Yeah, going back to the conference, the old Tesla conferences, the Coram brothers, who are with IEEE and I guess have worked with DARPA and this and that, or have always given their own explanations on the Tesla stuff, and like that tower in Tesla, going into all the Zenik waves and that kind of stuff. Gene is basically asking, where did the Coram brothers go wrong on their interpretation of what Tesla is doing with these, longitudinal transmitters type technology?
Where they're going wrong is they, by ritual, have to express everything in terms of what are called Maxwell's equations, which are actually the Heaviside Hertz interpretation of Maxwell's work. They're not really Maxwell's equations. There's no way to model unclosed currents in this particular format, and the expressions are entirely electromagnetic. All the other components are neutralized. So it really tells you absolutely nothing about what's actually going on. It's kind of more of a self-edification of these people to make them look like experts and continue to get funding, yet don't produce things that work, which is kind of rampant in our society. So they will never get it. I've been to these conferences myself, the U.S. Microtronics Association. I presented a 100-year anniversary theoretical and practical presentation of Tesla's transmission and vacuum tube methodologies. Rather proud of that effort. It was very difficult. It cost a lot of money. And that work is absolutely suppressed. Nobody can get a copy of it, and I was rather viciously harassed by the IEEE people that had come there, actually threatened. But at any rate, that doesn't bother me because I bite first and ask questions later, and my teeth are rather sharp. So when they got wind of that, they ran away. There was I believe, an International Tesla Society conference. I gave the Steinmetz equations on the hysteresis of the ether, which is basically the only way to scientifically access the Helmholtz view of electrical propagation, which is longitudinal and does not involve the velocity of light. That work vanished, and no one's been able to find that. The Coram brothers, they gave a presentation there, which got everything wrong. It was a nice exercise in mathematics, but it doesn't really, there's nothing engineerable out of it. I reduced this to basically pure technical or engineering formulation in what's called the Crystal Radio Initiative, where people could build these things and transmit back and forth with them, or derive energy from nearby AM radio stations, whatever experimental purposes or frequencies. There's not a lot of theoretical basis. There doesn't need to be a lot of theoretical basis. These things basically just connect and work. That's probably the most direct access you can have to this stuff. The two papers that I mentioned earlier give a good practical form of theory to understand these things, enough where you can do basic calculations and figure out numbers of turns and what have you and get an idea. I also presented in writing what I had lost at the psychotronics conference, in that I have solved the quaternion dilemma and have rendered them algebraic using what I call my method of multiple coordinate systems, something that was initiated by Steinmetz and General Electric and carried further by Dr. Fortescue in Westinghouse Electric. That is the basis for my versor algebra book. So I will be covering that to some extent in my presentation, even I'm going to try to focus more on physical practicality than mathematical abstractions, but we'll see how that goes. Now, the other delusional in this Tesla work is Konstantin Mile. He keeps wanting to run back to the scalar wave stuff. The scalar vector representation was thrown over the side a long, long time ago. It was completely harmful to any understanding of electromagnetism. Maxwell dumped it. Helmholtz dumped it. Heaviside dumped it. Larmor dumped it, but then indicated it still was a powerful tool of analysis. But at any rate, there is no such thing as scalar waves. That is an abstraction loaded onto a prehistoric notion before Heaviside, Steinmetz, and Kennelly, and J.J. Thomson and others formulate into engineering terms. And it tends to make you want to believe that the electricity is being transmitted in some type of electromagnetic wave through the air. I don't know, Tesla, how many times he said over and over and over again that the propagation was into the physical substance of the earth and not through the air, even though it could be. These people don't get it. And what they do is they kind of take all of the necessary knowledge that would be required to understand how Tesla and his scientific contemporaries viewed this thing and just muck them all up into basically what I call a self-edification, where they become the Tesla experts. But curiously, I'm the last person on earth they want to talk to.
Does that kind of answer your question, Gene, or do you have any other questions?
Yes, it does, as far as the Coram brothers, but what is it that they're being funded for in in Texas, then they're making claims. This company making claims that they'll be able to, send power via these Zenek waves. And no, they have this big plan that they're still going to have control of everything because it's going to go to substations in whatever country it goes to, and then from there you have to pay your utility bill to the substation, and it'll be all encrypted and coded, and nobody's going to be able to get free energy. But so what is it they're actually doing with their experiments down in Texas with this Texas tower?
Did you kind of give me?
Eric, yeah. Have you learned anything else about what they're doing down there in Texas with that tower and the Zenek wave claims?
Well,
by anybody who you...
What it appears to be, I have Zenek's book here, but his papers are in German, but his book is mostly practical stuff, which is actually very interesting for anybody that wants to go back to that wireless day technology, like what we're doing with the multi-wave oscillator and some of this other stuff that uses the old disruptive discharge methodologies and the magnetically coupled excitation of the Tesla resonator. Zenek talks about these surface waves. It was actually a German scientist named Sommerfeld who Ernst Gilliman was a pupil of. Ernst Gilliman was the focus of my presentation called Electrical Transmission and Multiple Coordinate Systems. He laid the groundwork for long-distance telephone. And he discusses a little bit about these surface waves in the introduction of his book. And Zenek gives a kind of a mapping out of them. They're Hertzian waves. They're exactly what Tesla said that he did not use. They do have a unique property that rather than dissipating with the square or with the direct inverse of the distance, they diminish with 1 over the square root of the distance, which represents a reduction in the attenuation factor, but it's not really directed. It's not really a longitudinal current into the Earth. It's ultimately no different than what's coming out of the AM broadcast tower if it's a quarter wave or less in length, unless they got some really remarkable trick that they found out or something up their sleeves or whatever. These people are not very communicative to the scientific or engineering world. They're hoarders. And then I saw a picture of this building. It appears to be, it's really no more than just another big Bill Wysock spark-generating Tesla coil. I guess they'll turn it down so it doesn't make that many sparks. Ultimately, this thing will play complete havoc in the world of electromagnetic compatibility and probably will cause all kinds of problems in computers and other digital equipment by the interference it generates. So I don't really expect it to go too far, but you don't really know until you get to the end of the story. But I've seen these people before attempt these Tesla replications, and I read their paper. It's all math. And it doesn't mention Tesla's name once, which really seems fishy to me. So I got the sense that what these people are trying to do is to repatent Tesla's work out of his name. I don't see how that's possible because Tesla's patents are very clear and they show novelty. Thus far, the only system I've seen that shows novelty is the Alexanderson system. That's why the Navy jumped on it, because the Navy is not interested in being involved in patent suits. So I don't see anything there other than the big interference generator, and maybe that's its ultimate purpose, is to jam out what's left of radio.
Thank you.
Okay. Yeah, any other questions, Jane?
Well, I would have a lot of questions for the guys in Texas, but Eric, some of what he has said, the voice drops, but anyway, I got the gist of it, and I appreciate that very much. Thank you.
Okay, sure. Let's see. Okay, I'm unmuting somebody else. When you hear that you're unmuted, go ahead and say your name, where you're from, and go ahead and ask your question. You should be unmuted now.
Can you guys hear me?
Yes. Who is this?
Perfect. My name is Ennis. I'm from Canada. And you know me, I've emailed you a couple of times. I was at the conference a couple of years ago.
Okay. Your name is Dennis?
Ennis.
Oh, yes. Hi.
Yes. Nice to hear from you again. I have actually a couple of questions for Eric, Professor Eric, but first of all, I would like to, I've been reading the Versor algebra book, and I'd like to summarize what I've understood so far, and I would like to hear whether or not, if I've gotten the gist of essentially what the book is trying to articulate. And so that would be my first question. And the second question I have is a understanding of how to actually apply the work. So first of all, from what I've understood about the Versor algebra is that depending on the number of phases you have a different set of electrical waves, the zero sequence, the positive sequence, the negative sequence, and the alternating sequence. And basically what ends up happening is after one cycle, they're all out of phase, so to speak. And so the Versor algebra allows you to kind of see that and then balance it so that you can have it all equal to zero at the end of the cycle using whatever electrical component will phase shift those waves so that they all meet up. Is that correct?
Yeah, that's pretty close. So this Versor algebra is not anything that I invented. This goes back to what's called the Steinmetz method, which involved a Versor operator, which in the vernacular is called the square root of -1, a grossly misunderstood term. So the first thing to do was to clear that up. And then the Steinmetz method historically basically made alternating current engineering possible. Before that, it was all mired in Maxwell's equations and differential equations, and it was just beyond engineers to take all that quagmire and turn it into something that worked. Then Steinmetz came up with the basic general principle called roots of the unit, but never carried it further. He was satisfied with his accomplishment, and he became quite famous, and his fame kind of went to his head and what have you. So he didn't really carry that theory much farther, but about I think about 1918, Westinghouse engineers and also to a certain extent Alexanderson from GE worked to come up with a more advanced representation of alternating current that would work with polyphase. And Dr. Fortescue called it the method of symmetrical coordinate systems. The paper that he wrote is nearly impossible to understand. So the complication there is it kind of lay dormant for a while, and Westinghouse was able to apply it internally. It was quite revolutionary for analyzing alternating current power systems because none of the waves that existed in the power systems were even known about until they were first arrived at analytically. Then thereafter, two Westinghouse engineers, one by the name of Wagner and the other by the name of Evans, came out with a book on the subject called Symmetrical Components, and then that allowed it to be applied by practical engineers, and it took off, and to this day it is the very basis of polyphase power engineering. This is not something that I invented, but it was never, the theoretical basis for it was never developed, which made it very difficult to understand, and it was never really developed into other phases like four-phase and what have you. And the interesting thing about this method of multiple coordinate systems, it actually provides a basis for numerology. Each number has a whole Pythagorean matrix that exists within inside of it, and this Versor algebra allows that to be accessed. So I kind of took this subject to its theoretical limit, but I also brought it up from the very basics of arithmetic and step by step through negative numbers and subtraction and logarithms and infinite series, devised a sound theoretical basis for this. And then in the later volume, then I show how you can actually apply this to taking the AC waves apart and putting them back together again. And then in my last presentation, it was applied vectorially to actual electrical engineering problems. And I think there can be appreciated of the power of that method of analysis in getting into these component waves in the electrical system, which can really play havoc with the system itself and what's connected to the system, like particularly induction motors, which are sensitive to these waves and burn out by a very minimum amount of imbalance, and emphasized also the particularly troublesome zero sequence wave, which is supposed to be blocked at every transformer bank, but now the transformers are being bypassed and configured in such a way that the zero sequence path now follows from the customer's ground terminal all the way back to the machinery in the hydroelectric or nuclear power plants. It's one continuous metallic connection, which is absolute insanity, but it's starting to become apparent we live in a society of absolute insanity.
Okay, and what I wanted to know was, so my particular interest of study right now is waveguides and resonant cavities, and as I'm still building the intuition as to how to apply the versor algebra, I just finished the derivations myself by hand, going through everything step by step. I must say I was quite impressed and also taken aback as to the derivation for the DC components that end up becoming the hyperbolic cosine and sine. I actually never saw the derivation before, and there appears to be a gap in how to translate, how to use the versor algebra when it comes to analyzing waveguides, because they're not traditionally, transverse electromagnetic. So you have the TE and the TM mode. So how would one go about taking that particular understanding and being able to apply it from a waveguides perspective?
Well, that's the next step. That's more difficult, and that's something that that was really being worked upon in the 19th century, was to figure out how to get to that next level, and they did not succeed. The quaternion system failed. The vector analysis methodology can be applied sometimes. In the case of waveguides, that becomes rather difficult. So this versor algebra, basically the versor algebra that's in the book and it's used for polyphase power engineering, exists in the metrical dimension of time. Now, when you get into waveguides, and particularly the Tesla transformer, this is where it's an absolute necessity. The method of multiple coordinate systems in that case is in the metrical dimension of space, and that opens up a number of complications. So that basically is presented at the end of the paper I wrote called The Theory of Wireless Power. That would be an introduction to the subject, but it's a very difficult and unresolved subject, so I can't provide you with like any immediate solution to the waveguide problem in that case. But in this upcoming presentation, I think I'll have it a little bit more quantified, at least with respect to the Tesla transformer, because it's not a transformer in the normal sense. It also operates as a waveguide.
I see. So essentially, to be able to apply it to the particular field that I have interest in, I'm going to have to take the next step that's kind of beyond the literature. I mean, I've been given the foundation to kind of walk upon, but pretty much the journey is on my own, aside from the introductory aspect that you mentioned, which is in the wireless power paper.
Well, there's two papers that you can go to that will give you a basic solid theoretical foundation in which to progress.
Okay.
They were written by Alexander McFarlane of the University of Austin, Texas. He contributed immensely to hyperbolic analysis and turning quaternions into versors and the whole historical development. I reference these papers quite frequently in the things that I wrote, but I'll give the names. One is called the Algebra of Physics.
Algebra of Physics.
If I remember right. The other one is called The Imaginary of Algebra.
Algebra. Okay, got it.
And these appear in the late 1800s, were presented to the American Association for the Advancement of Science.
Interesting. So, Professor, my question would be, like, one of the millennial prizes is solving the Navier-Stokes equation, which is a fourth order. So, essentially, if someone could conceive of the situation to be almost similar in the sense of how it's seen in electricity, breaking it down to those components, couldn't a problem like that also be solved through that same symmetrical component situation?
Yeah, the symmetrical component math was a lot of mathematicians picked up on that in the beginning, even though right now the mathematicians avoid it like the plague. But it immediately presented itself as a methodology for solving differential equations or equations in general to any degree. Now, doing that in time is easy because it's all in a plane, but doing that in space, that starts to become more difficult. But I think what I presented in the theory of wireless power at the end, and with the writings of Dr. McFarlane, I don't have a lot of mathematical ability. I just use what I learned in high school and what I invent myself. So I approach all this stuff from a very fundamental, basic form. But for other people that have a lot of mathematical knowledge, this stuff shouldn't be that difficult. And I think basically I'm kind of like the skeleton in the cave whose arm is pointing towards the way out, like in that movie, Journey to the Center of the Earth. And it's up to others to go through the tribulations and the brain torture of taking it to an actual practical level. But waveguides are a definite application. If a system of imaginary numbers can be developed to define all the energy interrelationships with various waveguide modes, I've always dreamed of that. But I have to try to do it with the Tesla transformer before this presentation.
Well, to be honest with you, Professor, I feel quite intimidated considering the fact that if you haven't still arrived at, then I don't find much hope in me doing so myself. I am a trained engineer, but it is something I am willing to continue forward, and something that I will continue to strive to understand for myself and try to apply it. My next question, which will be my final question, is I wanted to also, again, summarize for you what I've understood based on both the Lone Pond writings and your notebooks 1, 2, 3, 5, 6, and 7, specifically about the relationship between magnetism and dielectricity, and how essentially usually when they're taught as separate entities, but the way it's been portrayed in both your writings and in Steinmetz is that they're conjugate entities, they're attributes of one thing, they're not really separate, and you can't really define one without the other. And so one of the things that's kind of acted as a knot towards my understanding was the idea as to why the change of the dielectric field was measured in amps and the change of the magnetic field was measured in volts. And one time I was just thinking about this thoroughly, and I spoke to you on a call, I don't know, maybe 3, 4 calls ago, and we were talking about Walter Russell, and one of the things that you left me with advice was that it's not so much of what's engineerable out of his work, but rather the way he gets you to think. And one of the main themes that he has is this concept that you can't have charge without discharge. And so my question would be, is the reason why things are measured in their opposite units, so the dielectric is measured in terms of the amps, is because the only way for example, like the capacitor could only gain its field by consuming a current or returning that current back, and so that's either the backward displacement, which is when it's charging, and that's the forward displacement when it's discharging. So is every forward displacement turning to some kind of back EMF? Because my understanding is that if the capacitor is dumping itself, it's not dumping itself into something else, it's always dumping into its conjugate, because that's how it even got its energy to begin with. And so from the perspective of the capacitor gaining or losing, it's always the magnetic that's either giving or taking back, or not necessarily magnetic, consuming the current, whatever term can fit in there. But the point is that it's always the conjugate that's giving the other or taking back from it. And that's why one is always measured in the other. So for example, for the magnetic field, it's measured in, you have the EMF, the back EMF, and that's measured in volts, and that's because it has to consume a voltage, which is the other side, this conjugate side, it has to take from that side in order to develop itself. Is that an accurate way of understanding this? Because this seems to be the only analogy that I could create that could kind of combine the two pictures together. Because I did read at the end of your 4-quadrant book, you had one of the papers that's actually online, which describes the whole inductance capacitance things with respect to the 4-quadrant, and you did actually mention this concept, but it only came after you spoke about the fault conditions of both the the dielectric and the magnetic, and then after you substituted the open circuit or the short circuit with either the capacitor and the inductor, then you started talking about how one is dumping into the other. But my question is it always like this, regardless if you substitute that gap with the conjugate external of, for example, if you have a capacitor that's discharging, or if you open circuit an inductor, instead of open circuiting, you place the capacitor in there, and that's how you're talking about you can place the conjugate in there so it can dump into its other. So is it always like that, regardless of those special circumstances, and is that the way to understand it? I apologize if the question is a little bit long-winded.
That's one aspect, but then there's other aspects too. So you can have a distribution that's just either all dielectric or all magnetic that has two components, but there'll be no oscillation, but it'll have a distribution in space, like a ladder line, where you have capacitors in series where that's no longer capacitance, it's called elastance. Then you got capacitors in parallel, and that's capacitance. And the two merge together to give you a variation with respect to distance, but there's no variation with respect to time. You could put 100 kilocycles into the ladder network, or you could put DC, and you're still going to get the same form. But then you can take a magnetic version of that and a dielectric version of that, and then lay them on top of each other, like the Tesla transformer does, and then you can get a wave which is not electromagnetic. This volts and amps thing, I've pointed that out again and again, that there's some real pitfalls in using the volts and amps, because there's 2 volts and there's 2 amps. I don't know if you got that in any of the writings, but
yes.
In the sense of magnetism, the volts is electromotive force. That's transient magnetism. And then in static magnetism, it's conduction current. So the power of magnetism is the product of the electromotive force and the conduction current. Conversely, you have a dielectric field. If you have a displacement current, that's the transient part of the dielectric field. And if you have a static dielectric field, then that is the electrostatic potential. But the electrostatic potential in volts is not equal to the electromotive force in volts. And the magnetostatic or conduction current, which is not really current in the wires, it's the magnetic currents that surround them, that is not equivalent to the displacement current. They actually operate in kind of all 4 of them operate together. So I'm presently writing that up right now, but that was basically the whole foundation of the Lone Pine writing book.
My question was more...
Go ahead.
Sorry. I was just going to say, my question, I guess I didn't summarize myself properly. I do understand that there are different volts and amps, one being conduction current for the magnetostatic or the situation, and the displacement current being for the change of the dielectric field. What my question was is, every forward displacement somehow ends up turning into a back EMF? That's the whole conjugate thing that I was trying to get into. Like, so is every forward...
Displacement current at the boundary or the terminals of whatever, the network or the line or what have you, that's where it gets turned into conduction current. And the electromotive force, likewise, at the boundary of the transmission line or its terminals, that gets turned into electrostatic potential. But otherwise, as far in the dimensions of space, they, for the most part, except in the Maxwellian view of the electromagnetic theory of light, they exist independently of each other. But in the electromagnetic theory of light, then you only have the displacement current, the electromotive force, and you no longer have any conduction current or electrostatic potential, and then it has no need for a boundary condition anymore. Then it can just propagate into free space, according to Maxwell's theory. His theory is a theory, but that theory has been fruitful up to a certain point. And then when you start to get into Tesla and Alexanderson and what have you, the theory needs modification, or it needs to find a new basis. So the question is, let me refer you to one reference. J.J. Thomson wrote a book called Recent Researches in Electricity and Magnetism. And in there, he presents his view of an ether physics, a very fundamental ether physics that doesn't marry itself too deeply to any theories, mostly just to practical relationships. And he develops what are called Faraday tubes. And these Faraday tubes basically represent like a quantity of electricity polarized into the ether of space. And they're both magnetic and dielectric, and he departed from Faraday and Maxwell in that regard, in that there really is only one line of force, so to speak, the Faraday tube, but it has a transverse and longitudinal aspect. And then he carries that into a theory of conduction and what have you. I don't know what notebooks. I've got 1,000 pages of notes here, and there hasn't been a dime to get any of this stuff published, so it's not getting out there. I did explain Thomson's theory of conduction in my last presentation, and I think that's kind of adequate, and it shows that you can have your normal transverse electromagnetism, which surrounds the conductor and is bounded by it, but you can also have a longitudinal current which flows through the intermolecular elastance of the conductor itself, and this is what Tesla was after, and Helmholtz had thought that he had derived a wave equation for this. So now the question becomes, if this exists in a wave, there has to be two aspects, which are usually called, electric and magnetic. But in this case, it's not clear how the magnetic would manifest itself, because this particular type of current will not generate a magnetic field. So it has to be something within the molecular structure. So what we keep arriving at here is the science of electricity is not very well developed. And my objective to finalize all these things and develop a working theory for electricity, but the interest in it is so minuscule that there's not really the proper funding and manpower to carry this forward. And because of digital, electricity will be a lost science in about another 10 years or so. So I don't see any way around that unless somebody with the proper finances and power can get me to finish this kind of at a late start at age 66.
Well, Professor, if you could, I would just like one more follow-up question with regards to the Faraday tubes, because I have been reading the notebook that you're referring to with regards to the you going through the explanation of the Faraday tubes by J.J. Thomson is notebook 5, 6, and 7, and that was actually one of the first notebooks I purchased and read through actually 4 times. And the one thing that still hasn't made any sense to me is, so in the book, J.J. Thomson describes how the magnetic field is essentially developed as a pressure of I guess the way you would describe it is the broadside drag of the Faraday tubes. So it's kind of like a secondary phenomena, and not necessarily the primary. But what I don't understand is when you draw the tubes for the magnetic force, they're circling around the conductors, but to me, the Faraday tubes that are creating them are moving sideways to the actual conductor itself. But then you have the other tubes that are in that conjugate relationship, the dielectric tubes. So the way they were drawn is they were kind of piecewise, and I know they don't end in space. But how does the electric wave travel?
There's some question to that, because the way J.J. Thomson presents this is the electrification of the tube, because it propagates through the tubes, and the tubes exist always. Not just when it's electrified. They exist always, like a bowl of spaghetti. And then when they get snapped into polarization, according to Steinmetz and Helmholtz' view on the subject, that transient, in other words, the head end of that wave, still has to propagate with a finite velocity, which means there has to be something akin to magnetism associated with it. Now, one of the complexities when dealing with this, like in transmission lines and what you have to remember that there's two coordinates to power flow. There's the transmitted power that goes down the space between the lines, but there's the dissipated power that penetrates into the conductor. That's like the resistance. So when the electricity is finally used up at the receiving end, then it penetrates into the dimensions of the conductor, but when it's in the course of propagation, for efficiency purposes, you don't want it dragging into the conductor. You want it going down between the wires. So when you're dealing with the process of electrical conduction, the Faraday tube is going to be collinear with the conductor, but when you're dealing with the energy storage coefficients, you know, the capacitance and inductance and those kind of things, then it's going to be radial compared to the conductors. So you start to get into this really complex interrelationships, and of course this is what Maxwell and the work of some of his predecessors was to come up with this space algebra based on functions which they call curl and divergence to try to model this in space in general, but the problem is it really clouds the physics of the situation. It's better to adapt this into a method of multiple coordinates and deal with it in terms of versor operators, something that I have not yet completed, but I did give an entire presentation on it. I don't know if you saw that or not, called Electrical Transmission and Multiple Coordinate Systems.
Yes, that was the follow-up to the extraluminal transmission systems, and yes, I definitely did see that, and to be honest with you, it's slowly sinking in because I still have a very hard time, because I'm a visual person when it comes to understanding things, and it's so hard for me to imagine. I see the diagram of the electromagnetic configuration of the lines of force across two conductors, but I can't see how these things propagate down the line. It looks a lot like a stereographic projection of a sphere on a rectangular plane, and I always wondered if it had anything to do with that, because if you took the longitude, latitude lines of a globe and you project it onto a plane, you get exactly the same configuration as you do with with the concentric circles of the magnetic field and the longitude, the dielectric lines of force. So, is there anything related to that between those two, or is it just a coincidence?
Well, that's kind of an idealized representation, and it's based on the coordinates of the conductors, which are circular. So if you were to try to map the field, like with a number of wires side by side, like in a Tesla transformer, because not everything's happening at the same time, and that you have complementary coordinate systems, then that modeling becomes very difficult. Now, this is a problem I'm facing for the presentation, is I need somebody who is competent at it, because of all my reference books, I don't have one book that shows me how to do basic field mapping. But I need the field map not only for the transverse electromagnetic between bipolar conductors, but there's three other field mappings that I also need where the current goes in the same direction in both conductors, but the electrostatic potential is still bipolar, and then conversely, the electrostatic potential is equal on both conductors, but the current is bipolar, and then I need one where both are monopolar, and then we already have available the one you're talking about where both the current and potential are bipolar. I need all four maps made so that I can start to figure out how to overlay the stuff and come up with what actually is going on in this propagation down this particular waveguide called the Tesla transformer. The whole thing is, this is all basically, it's not all worked out. It's still basically scientific. So it's a struggle for me, and it's going to be a struggle for others who try to get involved with this. But for those that have more mathematical ability than me, I've rendered as it as simple as possible in the realm of mathematics. I think it's as much as is humanly possible to do. And anybody that is very competent in the more abstract mathematics can go to the references and then take it to the next level. But it's a lot of work.
Mm-hmm.
It's difficult.
Okay.
So that's
well, if we can get on to another...
That's what you've engaged in. So basically, keep yourself pumped up with B vitamins because your brain's going to burn like gasoline.
Thank you, Professor Eric. I appreciate it.
Also, it really helps to go out in nature and get away from all of this mechanized delirium and mutation that we live in, and get out into God's creation and with this stuff in your head, and you'll find that you'll get a lot of answers that way. That's how I did it a long time ago when I used to live in the redwoods.
That is something I will definitely do. Thank you so much for your time. I deeply appreciate it.
Okay, you're welcome.
Okay. Yeah, so Eric, that was Anis, who was one of the 4 students who had the scholarships come to the conference when the conference was downtown Coeur d'Alene, and you gave the Power of Ether presentation. He was one of the 4 students that was there, yeah. So,
yeah, unfortunately,
let's see,
it wiped me out so much I really didn't have much time to interact with anybody.
Yeah. Let's see. Okay, we have somebody who has a question. I'm unmuting you right now. Go ahead and introduce yourself, your name, where you're from, and go ahead and ask your question.
Hi. Can I ask the question?
Yeah.
Yes, go ahead.
Hey, hi, Eric. Abhishek here is from India. I've got a couple of questions, one on the business end, one on the scientific end. So on the business end, I would like to know the current status of the musical systemic wave project, which we are doing, and you said last time that there is some development to be done and there are some limited funds to be required, so I would like to know about that. And the second thing is that would you like to participate and do a bit of conferencing or maybe work a bit out in other continents like in India as we are from?
Okay, well, the first question, the musical seismograph project basically died. No one is interested in putting the necessary money in to build the facilities, so I have most of the equipment, but I do not have the means to. A lot of the equipment has to be stripped to be built into other equipment. I have no laboratory, so there's no way if I started taking this equipment apart to get these very critical components that I need to build this thing, the stuff piles up and then I have to stop. So that kind of chunk right there. I did get one amplifier built, sitting on the bench right now working. We have to build a terminal facility in the mine, kind of like a bunker. It's got to be built into the portal of the mine to keep it from getting too hot or too cold in this horrible environment here in central Nevada. It's either the ice age or it's the furnace of hell. There's no in between. And then the racks go in there where the amplifiers and everything else goes. So basically, I roughly estimated I cannot get the cooperation to get actual estimates from contractors or whatever. I have no help in this. No one will help me with this, and I don't have the money to hire any of these people, so it's kind of a catch-22. But I'm looking at $250,000 altogether to bring this building into a state where it's got the proper electricity and the shelves and the proper benches to install and construct this equipment, central office
and it has to be done out there in Nevada itself, or it can be done somewhere else.
I didn't get that. Can you repeat it, Aaron?
Yeah, it has to be.
Yeah,
done out there in Nevada, or it has to be. It can be done somewhere else as well.
Well, in order to do it somewhere else, then it's all got to start from scratch. So right here, there's a number of reasons why it ended up here. There's some serious drawbacks about this area as far as interference, but as far as the musical seismograph end of it goes, the facilities here to start all over again and dig a tunnel 1,000 feet into
I get it.
And to find the seismograph transducers that we have in there that were donated by the university, it's out of the question. When this gets perfected and one system is up and working and somebody wants to spend the necessary $1.5 million to build another one somewhere else, that's a possibility, but there's no point in me building one for someone somewhere else when I can't even finish what I began here. So until this gets finished, it's not going to extend anywhere else. Now, as far as the seismic forecasting using the Alexanderson system goes, that would have to be built in areas close by here. We already have completed one transmission facility in the Mojave Desert, but there's absolutely no money to lease the necessary space in the microwave building to put the terminal equipment. And in Owens Valley, which is kind of a combining point between the Great Basin where I'm at now, the Mojave Desert, and the Eastern Sierra, that is the optimum place to put the Alexanderson system, mainly because it's right in the fault system, and the city of Los Angeles Water and Power is a utility, and their electrical utility is all Delta connected, and there's absolutely no interference, and they own most of the land, and it would be possible to put in the Alexanderson receiving system there. But as far as the seismograph, the mechanical end of it goes, you have to tunnel into a mountain, and to get permission to do any of these things anymore, and what have you. But once the system is developed, the antenna, we have our test site here that was given to us by the government where we can develop the Alexanderson antenna and come up with the final engineering plan. Then that can be produced pretty much anywhere because it's basically just poles, wire, and insulators with associated amplifiers. So what I've done as an emergency stopgap measure, with great difficulty to get any cooperation or any help out of anybody, it's damn next to impossible. I don't know what's happened.
Right.
They really become worthless. But at any rate, I've got one telluric receiving system cobbed together on the midsection of the San Andreas Fault, and plans are underway to put another one together. These are just, field telephone wire on fence poles, with ground rods and nothing, no waveguide action or sophisticated ground electrodes or whatever. They're just brute force. And the objective is we need about maybe like $10,000 or $15,000 to get this together, which is not forthcoming. And the people who have the property to put this on are much less than interested. It looks like it's about $10,000 or $15,000, and to get this, we'll get one of them on, hell or high water. We'll get one of them on the air within a year on the internet, and the objective is to get both of them on the air, on the internet, and then have a stereo, ultra-low frequency receiving system into the San Andreas Fault, and with no filters or whatever to pick any, precursors out. It'll just basically just be, the music of the earth, and it will go nuts before a major earthquake on the San Andreas Fault, and then there will be, at that point, there'll be no denying that this methodology works. So this is kind of what I'm pushing towards now, because the necessary funding to do this, on a Bell system level, is just simply not forthcoming, and the clock is ticking.
Exactly. That is why I'm calling. That is why I'm calling. I had a discussion with Aaron on top of that. I'll send a mail, and maybe Aaron will encourage something which we are talking over another call. One more thing which is very important. Can we build the infrastructure on the same infrastructure to make the communication, both-way communication across the Earth or on any point of the Earth for any kind of data travel? Like it's almost like internet kind of stuff. Is it possible on the basis of this infrastructure from point to point on Earth?
Well, the problem with wideband doesn't work at low frequencies because the bandwidth exceeds the frequency that you're operating on. But as far as a narrow band, like, a backbone communication system in the time of disaster or war or whatever, that's totally feasible.
Even in the morning at about 5 in the morning tomorrow morning.
Okay.
Now if the International Telecommunications Union will allocate the bandwidth in the low-frequency band, it is possible to have one reasonable digital channel, but to meet the bandwidth glut desires of the human race at present is not feasible, and that is what has destroyed the Bell system, is this bandwidth gluttonry. And it's just going to be like freeways in L.A. They widen the freeway, and then you get on it, and it's still jammed. And they widen the freeway, and you get on it, and it's still jammed, and this thing is just, once it goes to 5G, this thing's going to choke itself, and people are going to be so addicted to this I want it now reality that there will be no more realistic communication systems available whatsoever. So just for security purposes, it would be good to have a network of telluric communication systems. I think the Navy would like the idea. And it's not really that expensive to do that because it doesn't involve a lot of, transmission lines or whatever. It's pretty much, the Alexanderson system would, but the Tesla system's more fixed. But the Tesla system cannot operate any wider than a normal telephone channel. But the Alexanderson system is capable of much wider operation, but the frequency allocations would have to be provided. But there's not really too many people using any of these bands anymore. So they are available for alternate forms of communications, and that's kind of one of my objectives. So the test site antenna here, we have 2.2 miles of right-of-way. Right now, what's mainly lacking is we need 5 miles of wire. We're attempting to work with AT&T to be able to take down some of these abandoned lines and get some of this equipment, which is very encouraging, but the complication is I can't find anybody that will lift a finger to help me with any of this, and there's no money to hire contractors. So I'm starting to...
And what is the kind of money you're looking for this?
Well, right now we need $250,000 to basically finish our physical facility here. So far, we have about $250,000 into it. I think Aaron might have a better idea, but I think we put pretty much close to $100,000 into the building, getting a roof on it, getting the walls back together, getting all the junk out. And then a lot of work was spent on securing the lines that the government provided to us out in the desert that were abandoned by the utility companies. We had to replace dozens of poles, take down broken wire and shattered cross arms, and a lot of that activity is photographically documented on the website. That took years, particularly being
right.
I only had one person that was really competent and had the stamina to help me with it, and then he quit and walked away mid-span, and now I have all these liabilities out in the desert that I can't take care of. So it's created problems in my life. But at any rate, getting back to the primary focus here, there's 2.2 miles of right-of-way here. The cross arms and insulators and the poles are up for 1 mile of Alexanderson antenna. We need 8 ground electrodes. The contractor estimated roughly $2,000 a piece to bore the holes to put the ground electrodes in, and we need 1 mile of wire. Unfortunately, I have nobody to help me do it. So that means I would have to hire contractors, and that would double the price. So until
that is what I'm going to talk. Yeah, exactly.
Yeah, so I'm stuck. I'm basically stuck, dead in the water in this situation. Enough money used to come in to pay all the bills and, get me the supplements and the books I need. And right now I need to put $2,000 into my Corolla. I got the 700,000-mile repair interval coming up here, and I need to rebuild the transmission or replace it. before I go to the conference, that money's not forthcoming. It's expensive to keep this building warm. It's about $300 or $400 a month when it gets 0 degrees outside, like it's doing now. There's barely enough to do that. People are less and less interested, and this stuff is sitting. Basically, I got mud on my face by being brought here by Bell Telephone and put in place to do all these things, and get initially started on it, and then it's all dead. And then it makes me a liar.
No, I'm really interested. Yeah, I'm really interested. I have a group of people who are also interested with me from India. I want to talk to Aaron specifically on that. So that will be, I'll let Aaron know very soon. I'll write him a mail. Maybe we'll have a conversation. One more question which is there in my mind is that, is there a superluminal communication possible through below the Earth from point to point?
Yeah, it's hard to say whether it's superluminal or not until it's actually built. But to build the Tesla Wardenclyffe-style transmission system is just a simple technical matter.
Okay. And how much time
as far as to what the delay and attenuation is, that's not known until it's actually done.
And how much time?
But these things are all basic. They're basic engineering. There's nothing that needs to be experimented with as far as the Tesla method goes. The Alexanderson system needs a little more refinement, but the Tesla system is good for just one channel, like one voice channel or one teletype channel or something like that. It's fine. It's important to get that done. There are some abandoned facilities that already have the ground electrode, which is the very expensive part, preferably an abandoned AM radio station. There's a lot of abandoned long-wave aeronautical beacon stations. There's one very optimally located in the San Francisco Bay Area. The building is abandoned. Maybe some of these things can be found to obviate the cost of putting several miles of wire buried in the ground, or some massive set of shafts like there is below Wardenclyffe. You can find something already made. Then it's not very expensive. With this Colorado Springs replication effort and the Crystal Radio Initiative, the Tesla transformer system is reaching finality as far as engineering goes. The only experimental part left to be done is getting the extra coil optimized to the secondary, and then once that's done, then it's just a simple matter of arithmetic and mechanics to put one of these things together.
Any idea if it could be done from the scratch, and what can be the fund requirement and time requirement for that?
I didn't get that one. Can you repeat it, Aaron?
Yeah, I'm basically asking, like, any idea if it can be built up from the scratch, and what can be the cost as far as time as well as expense is concerned?
Yeah, I'm not. Can you repeat
that? So starting from, if somebody was to start from scratch to install one of these, put one of these installations in, what would be the timeline and the cost, for a communication, one intended for communications?
Well, that's kind of hard just to say off the top of my head. First you've got to find the right spot. So if the ground conductivity is poor, you have to use Alexanderson system. If the ground conductivity, like a saltwater marsh or something, is high, then the Tesla system, the cost, I cannot estimate the cost. The time for anything like that nominally is like 6 months, assuming that you have all the proper people. But you also have to get the frequency allocation from the International Telecommunications Union. You can't just do this. You have to get a frequency allocation, which shouldn't be a problem, because, like I say, these bands are all, they're not used anymore. It's really very discouraging to me that I can't get my weather information or solar information or any of this stuff. Radio's being taken away. So there's no radio anymore. I guess, you can put anything you want on it unless the particular Reich that you have to operate under, disapproves of that and then bulldozes it on you. It would probably be, I would imagine it would be the Navy of of any specific country that would be the most interested in this, because it's ideally suited for ship-to-shore communications, because you can transmit through the salt water. It's
right.
Like I say, that the amount of delay and the amount of attenuation is still unknown. So until a pilot station is built, which I basically have the parts for a small one, which I wanted to do from here to the government research facility in the San Francisco area. That's how I would start, but the thing is there's not a lot of interest in the people on the other end, and I don't have a laboratory in order to connect the power up or whatever for any of these things. So, but the extra coil is being finalized on that project. The transceivers have already been purchased. The primary and secondary coils have already been constructed, and that operates in an amateur radio band, kind of orientated more towards a short distance, kind of a rough experiment to get an idea of what kind of attenuation may be involved with this. So there's a number of possibilities if I had a laboratory here and could pay the people to help me with these things. You start doing this stuff.
I get it.
It's already laid out. One of the reasons why I chose this building is it has a massive ground electrode buried outside, absolutely massive. And there's a lot of alluvial drool off of the hillsides around here that keep that ground conductive. And also, I have a standpipe from outside the building next to it that connects to the original gas lighting system here in town, which gives me another grounding element. So I've got one hell of a ground here. And then another place would have to be found that has a similar ground, or that would have to be constructed, and that's what would cost some money. So I've been trying to get some cooperation to get some space at this government facility over there in the San Francisco area, but everybody's in such a fog, and their life is so filled with distractions, and their problems and whatever, and it just doesn't go anywhere, and I just get angrier and angrier that I'm in this frozen state. Nothing's moving. Meanwhile, every day I get older and one step closer to the grave.
No, I think I completely understand that. One more thing which is very important, like there are very good number of young budding engineers who are willing to work with you alongside you out there and learn a lot of stuff. So is there a probability or possibility that they can actually do that with you?
Well, as long as they're competent and they're not mentally deranged and they have the money, to pay for their food and lodging when they're here, that's kind of what this place is for. I just had somebody here, help me out. Came from Florida, and he had enough money for his own food and lodging and whatever, and he cleaned up the pole yard in the back here, which was desperately needed. It was all overgrown with weeds and what have you, and I got some other people that might come to help me move some equipment around to make way for what might come in from AT&T, so that kind of saved the day, and then, so he was able to fend for himself, and then he showed up here during normal working hours, and and as long as there's no weirdnesses or psychopath, type stuff or whatever, if they're cleared beforehand that they're not going to be a problem, and, maybe they'll have to sign some kind of statement that they're not going to get in trouble, and it'll have to be approved by the board of directors, Aaron, and the rest of us, then we can move ahead on that if there's money to do it and there's the necessary materials for them to be able to do something. If there's no materials to do anything here, then it does, it's like I could have 100 people here right now, but it would be useless because there's no materials to build the shelves. There's no conduit and wire to put in the electrical. You see what I mean?
Right. I completely understand. Right.
So
I have one last question.
You reach kind of a point where is it economically more desirable to have volunteers that aren't necessarily experienced and then have to go out and hunt for the materials, which is kind of hard in the middle of Nevada, or is it more economically justifiable to hire the proper contractors who have immediate access to the material, have all the technical ability, and get in and out and get it done? So if you see what I'm getting at, there's kind of a balance.
I get it.
What would be the best way to go? And because I think in terms of the United States Navy and Bell Telephone is nothing's done here without a plan.
Exactly.
There's got to be a plan.
Right.
It can't be hysterical society stuff. I've gone through too much of that here. I've gone through too much of that in trying to restore these historic Navy ships. Is you get these volunteer crews that show up and everybody's running around like they're on fire and there's no plan and nobody knows what to do and things are getting broken and it doesn't get put in right and then everybody runs away and leaves me holding the bag for the rest of the week.
I understand completely.
That's a situation to avoid. But
right.
It can be avoided.
It will be taken.
Okay.
You know, if
We should probably wrap
if America landed man on the moon, then it's possible to put this together, even in this level of a deteriorated society, because none of this is really out of the ordinary. It's just standard stuff.
I understand. I have got only one last question. It's more of a scientific question. It's like, is there a radio wave possible as far as the propagation is concerned without sun or any source of light in this complete solar system?
I'm not certain about that question.
Okay.
Yeah, can you elaborate on your question?
Yeah, exactly. Like if we don't have our power source, like we use the sun as a power source, it gives us light, and we use that light in different formats, and we get charged with the help of those light and all. So if we don't have sun as in to power ourselves or anything as such, so will that be difficult to create radio waves to propagate from one place to the other?
Well, the presence of light is not necessary for the propagation of electromagnetic waves. But it's a question whether the light itself is an electromagnetic wave or not, because apparently direct light cannot be seen in outer space. And if that's the case, then this Einsteinian notion, that they so are dearly attached to, that, it takes so many light years for light to get from one place to the other, may be completely false.
Right.
I'm convinced that it is. There's only light when this particular force field, or whatever you want to call it, hits material objects. You can't see light in space. You only can see it when it hits material objects, or it comes from a material object in our atmosphere. So I've always toyed with the idea of coming up with some way to communicate across vast distances of space without the limitations of electromagnetism, but I can't really say exactly how I would go about doing that. At this government research place I was mentioning, there are retired people that have been involved with that through the SETI project. They have that interest and they have the theoretical knowledge, but when I try to get any cooperation out of these people, they just, all they want to do is like withdraw into their hole and, I'm retired, I'm not into that anymore, I don't want to talk about it. But I'm rather pushy, and I haven't given up on that idea yet, but there's not enough interest in it, and I don't have a definite engineering plan, so that's not a priority right now. I got plenty of other priorities, like writing up all these presentations.
Exactly. So, to continue that question, the question belongs like, is there a possibility of intergalactic celestial internet on top of radio waves?
You want to transmit internet intergalactically? Is that what you're saying?
Yes.
Well, that wave would have to be discovered. That's what I've been talking about. If it's feasible or not, it should be. Anything's possible in God's creation if you just put your mind to it. All it takes is 3 or 4 people to get together and say, this is what we're going to do, and historically they do it. I mean, everything that we are engaged in right now at one point in history was declared impossible. So, but the problem is that this Einsteinian scientism has just choked everything into a standstill religious situation, and then the Internet is making it worse. So kind of like the window's closing. If anybody wants to move ahead on this stuff, before all the people of my generation are finally dead, and most of them are, because I started at the age 6, and they started much later, and now they're all in the grave, and I'm one of the only few left. The time is now. And
Exactly.
if anybody, if there's people that have this ability that aren't just using it, for a dog and pony show like this Constantine Mile and the rest of them, but are serious theoreticians and engineers and want to put their mind to this, I think it's possible. But it'll have to be derived experimentally, and it's going to take a lot of brain torture. But I can't see why it should be impossible. So my objective is to start with something I know that works, and that's the telluric transmission system, and see where it goes from there.
Fantastic. Thank you, Eric, very much, and thanks to Aaron as well. Aaron, I'll write to you right now about what could be done from my end specifically and the timeline about it, and it would be great if we could have 1:1 arrangement as we specify on the mail.
Sure. Yeah, we can schedule a Skype call sometime soon, and I'll look forward to your email.
Yes, I'm absolutely looking forward to the union, and I'm absolutely desperate to go ahead with Eric because this is time, and he's a man in one in a millennium. So let's not waste any time about it. I'm absolutely in game with my team.
Okay.
Thank you.
Good. Look forward to talking to you. Okay. Thank you.
Thank you.
Let's see.
Thank you.
So it's 2:38 right now. We can see if anybody has maybe one or two quick questions, and we can go ahead and wrap it up. If anybody's still on the call that has a question, hit 5*, and that'll give me a little sign by your phone number, and I can go ahead and unmute you. In the meantime, definitely please check out ericpdollard.com, and if you can help share that on Facebook or Twitter or whatever social networks you're in, and help kind of spread the word about Eric's work. And if anybody is able to donate, there's a PayPal link, and there's a mailing address if anybody can send a check or money order for anything that they want to help contribute. Again, it is a 501c3 nonprofit corporation, so it's all donations are tax deductible. And if you go to ericpdollard.com, you can look in the right column, scroll down a little bit, and you'll see all that information. And also there's, if you want further information on Eric's work besides what's on his website, you can go to emediapress.com, and you can scroll down to all of Eric's different presentations. And also there's, I have two forums, energyscienceforum.com and energeticforum.com. And if you go to energeticforum.com, there's a handful of Eric Dollard threads. Some of the old ones are closed just to kind of preserve them so nothing happens to those. And there's a current one where, if you scan through there, there's quite a bit of Eric's work posted, and there's some, other people are posting in there too. For example, somebody named Bruce had replicated a version of the cosmic induction generator, and he shows the flame speaker on there and the plasma bulb with some of the interesting plasma inside there. And so if you're interested in keeping up on stuff and looking through there, and if you're involved with any of the experiments, definitely share whatever you're doing at energeticforum.com and Eric's threads. And a couple of times on this call, Eric has mentioned the Crystal Radio Initiative, and that's at crystalradioinitiative.com. It's a whiteboard presentation. It's only like $7, but that gives a simple walkthrough on how to build a Tesla-style crystal radio to receive an AM station through the ground versus electromagnetically through the air. And when that's constructed properly, it gives one the ability to actually maybe power tiny little bulbs or little motors actually powered by the AM station through the ground longitudinally. And so that's at crystalradioinitiative.com, and that's probably one of the simplest projects somebody could make, I suppose. But it's a very simple presentation that if anybody wants to look into the Tesla-style transmitter technology, that's probably the simplest presentation that's available from anything that Eric has done. And so, again, if there's any last-minute questions, go ahead and hit 5*, and I can unmute you. Otherwise, do you have any final comments or anything, Eric?
No, not really, but are there any of us on? Is Bruce Gavin or Robert Eamon there?
Let's see, Robert's on here. Let me unmute him. You there, Robert?
Yes.
Yeah, why don't you kind of fill us in a little bit on J.J. Thomson and what went wrong, because you're pretty hip to that.
Basically, the whole area of science and physics was basically hijacked starting in the 1890s. They had a rough time because the Steinmetz proved them all wrong. So they had to wait till they could finally convince Steinmetz to side with Einstein, and that was the nail on the coffin, along with the 1919 under Roosevelt nationalizing radio. But if you look at J.J. Thomson's work, he has an excellent model of the atom, and it works quite well. But they just rejected it, and they adopted the Bohr model, and that is not good at all. So basically, it's about money and power and not about what works and what's good science.
Okay, that kind of sums it up quickly.
Anything else you want to add to that, Robert, or anything else, Eric? I'm not sure if Steve or Bruce is on.
Yeah,
let's see if Steve. Yeah, if Steve or Bruce is on, go ahead and hit 5-star, and I can unmute you if you're available.
Yeah, maybe Bruce can just give us a little bit on his efforts to put the scale model together.
Okay, yeah, it doesn't look like he's on.
Okay.
At least not the number that I have for him.
Okay. Well, maybe just a couple of questions then, short ones maybe. I'm not tired, but you probably got to.
Okay.
I can keep going forever. You know, I have my coffee latte this morning, so I can work my.
Yeah.
Yeah.
Yeah. Go ahead, Robert.
Aaron?
Yeah.
Yeah. My big wish list is to somehow preserve these old books, the books of J.J. Thomson, especially his book, The Textbook of Physics. There's actually two parts on electricity. One's electricity and magnetism. The other one is electricity it's magnetism, electricity, and then electrostatics and magnetism. It'd be nice if we could find these old books, the original books, and somehow preserve them in a library. They're becoming harder and harder to find, and also the other books done by the old masters of electricity. It seems like there's a widespread book burning going on. I used to be able to find these kind of books. Now they don't exist, and it's a real predicament for me.
Yeah, fortunately, at least a handful of them are on archive.org, where you have the original scans. And at minimum, I'd recommend everybody go there and download them. And it doesn't cost that much to print them out and have them put in a spiral-bound, book at, Staples or Office Depot or something. Because some of these books, all I can find are modern-day reprints, like on Amazon or Abe.com, and they're not always perfect. Sometimes they have missing pages or not edited very well. But once in a while, if we can get an original copy at a decent price, that's what I grab and send down to Eric. Let's see. We do have, Anis has a question. I'm unmuting you right now. Oh, yeah, go ahead and ask your question. And if we can kind of keep it brief, I'll have to wrap up here within about maybe 5 minutes or so.
Perfect. I actually just wanted to ask with regards to when the updated version of the Versor algebra book will be posted. So for those who already purchased the book, if they will their download files be updated with regards to the new content as well? I just wanted to confirm that.
Yes. So whatever the version of the ebook available on through versoralgebra.com. It was about maybe a week ago or something like that. I got the edits from Eric, and so as soon as I can get some time, I'm just swamped with the MWO manufacturing project. But we're just kicking off the conference promotions and stuff. But as soon as I can get those edits into that will be re-uploaded as an ebook. So anybody who has the ebook, it'll be the same username and login. To download it, and I'll send a notice out to anybody who has gotten Versor Algebra in the past so that they can get the upgraded version for free. And then it just needs to be reformatted in a 6x9 Amazon template. Then we can get it on Amazon as a paperback. So the timeline, let's see, this is the beginning of February. And I'd like to actually get it done by the end of the month and at least have the ebook updated and available.
Okay.
That's about all I
just want to
mention
right now. One very short question. Would Professor Eric ever consider doing a workbook, like a very small workbook of examples with regards to the versor algebra, or is that already included in the updated the content stuff? Of work through, like examples that are actually worked through with the versor algebra, because there's only there's a small example in the lecture that he was mentioning at the end, but is there anything like that in the updated contents of the book?
Yeah, that's the third volume that I am not in a position to write, but in my last presentation, I apply that methodology, and you should get the books that I reference that go with it, and that's it's called Symmetrical Components, and the author are Wagner and Evans. I would highly recommend that you get that book and see this system in its more crude form, actually applied to electrical engineering problems.
Perfect. Thank you so much. That's it.
Okay. Yeah, and that last, let me give the website of the last presentation as well. Let's see. Okay, so Eric's last presentation, just give me a second here, is the history, theory, and practice of the electrical utility system, and that's available at emediapress.com/Eric Dollard/utility, and that's actually like a 5-hour presentation. That's the longest one so far, but that includes the about 5-hour presentation in the MP4 inside the zip file, and there's also a PDF of 774 slides. And originally it was even more than that, and I know because I put probably almost 200 hours into assembling that PowerPoint with Eric.
Yeah, it actually.
So,
computer.
Yeah, right. That was quite a file. Let's see. Okay, well, if there's no more questions, I guess we can go ahead and wrap it up. Any final comments, Eric?
No, I think we thoroughly covered the subject pretty good. I'm kind of encouraged that, that people are starting to intellectually grasp this and ask intelligent questions rather than, wondering when the last spaceships landed out at Area 51.
Right. Okay, and again, ericpdollard.com, and if you want to come to the conference, meet Eric in person. He'll be giving those 2 presentations. It's a Thursday, Friday, Saturday, Sunday, July 11 to 15 of 2019. It'll be the 8th Annual Energy Science and Technology Conference, and that's in Hayden, Idaho, which is about an hour drive from the Spokane International Airport in Spokane, Washington. And over those 4 days, there's going to be something like, maybe 17, 18 different presentations. There might actually be maybe 21 or 22 presentations, including the business ones. We're in the evenings after dinner, we'll have an attorney talk about business considerations and compliance. Another attorney is going to be talking on intellectual property law versus open source and that kind of thing. And then on, Saturday night, my friend Shannon Gronich is going to be talking on fundraising. And then on Sunday, after the 2 panel discussions, there'll be a talk on contract manufacturing and using PCB and schematic type software. So if anybody has inventions or little circuits and they want to know how to actually get these into the marketplace and have them produced and sold, those extra presentations there are going to be necessary, because a lot of people who are tinkerers and experimenters and stuff may not have the the experience in those kind of things. So we're going to have some experts talking on each one of those subjects. So EnergyScienceConference.com is the website for the conference, and again, it's limited to 150 attendees, and already about 20% of the seats are already sold out. And this conference will probably sell out by May or so. It usually does every year. So anyway, thanks to everybody for being on the call, and appreciate you spending time with us, and thanks a lot for your time, Eric. and I'll get this up on YouTube, maybe in the next week or so, maybe by this weekend. So thanks a lot, everybody. See you next time. Thanks, Eric.
Goodbye.
Thanks, guys.
Okay. Thanks. Bye, everybody.
Yeah.